just try to like throw you a light on this, on the project execution flow and control gates. We don't do very much different what the industry follow. We just follow the V model of the project execution process, and it is the part of the, whether it's mostly into the waterfall iterative model, which we do follow over here. And in that process, it's the V model. We have the two tracks. One is the development is following that one track. Another one is the testing is following one track. And the time of the testing, the final release, this testing is taking over it. But only thing which is you might have little different over here is we have the different control gates into this project project execution process, that from one phase to another phase, when I move over there, we have the established control gates which ensures that the previous phase which is supposed to complete, it is completely completed, and it is completed in 100% of way. Actually, there is nothing missing out of that. So that's the only one thing you can think about, that we are trying to include some of the things into the project management principles. So in that, it's not a new slide for you. It's you all guys must be looking into this, and only this, there is just some tailor-made changes has been done into it, which includes the how the project management execution flow could be controlled at the control gates, and the feedback process could be send it back to the previous phase to take a better control in the next cycle. So here the most important part where I'm trying to showcase into the slide number 11, you all must be seeing that the left hand side which I'm trying to show is it's not a new graph for you, it's not a new S-curve for you. You all guys must have already seen it. I'm just saying that we have the 5 phases for the project management: initiation, planning, execution, control, and the closure part. And the other side, I'm trying to just showcase that there is a SDLC process is happening. But what most important over here is you might be seeing that there is a yellow line in between the all 4 lines. That's the area I wanted to focus more. That's the area I wanted to bring all of your attention, that why I'm trying to showcase that yellow line in between those all 4 graphs, because we are utilizing the knowledge repository of our organization Mindtree as well as the baseline data of our Mindtree to the fullest possible level. We have the very good statistical control system into the organization. We churn the data, we crunch the data, we take out a lot of information out of it, and then we create a baseline how the SDLC phases must be controlled by the project manager. So I'm just trying to debug some of the things, like when I'm talking about the SRS, looking into the right side of the graph is SRS, then I'm talking about system requirement specification, CUT phase, coding and unit testing, MST when I'm talking about the system testing, when I'm talking about the SDV, it's system design validation, and when I'm talking about the UAT, you all know about, is the user acceptance test. So you must be seeing that this graph is little up, down, up, down. This graph is non-linear only because as per the organization baseline data, these are the areas we are trying to focus, that if I have to achieve the zero defect into the UAT, when at the rightmost side of the graph, that's a zero defect, I'm trying to achieve the zero defect in the UAT phase, then there are the phases at which level I must be able to like control my quality of deliveries at this level. So when my developer is working on the SRS level at the time of the requirement and the specification level, I have the set of the goal. This is the data which you are seeing as of now. It's a dummy data. It's not a data which exactly reflects the Mindtree standard data. But this data is, I'm saying that at the requirement stage, you must have a goal set for your entire team, that this is the how you must finish your system requirement specification phase, that how well you can say that yes, my requirement is closed. So this is the stage we have the set standards, and with that set standard, we drive our team to achieve that goal at least. So the line which you are seeing at the bottom of the yellow, that is we call it the lower control limit. That's a lower control limit. And the line which you are seeing at the top, that is called upper control limit. And the line which is just near the goal, that's yellow color, that's the goal at exactly, that's between that line we wanted to drive our project, but meeting that goal line always remains a kind of challenge. So basically we need to always try that actual, whatever the actual you are achieving into the project, it should be going parallel to parallel in between the two control limits to the goal. So if you follow this kind of the chart, our experience has been that we have been able to deliver the quality deliverables to the customer with the zero defect. I have a lot of details on this chart. You can sync up with me offline, and I will try to share maximum details, all the engineering details on those software development life cycles part. So I'm moving to the slide number, So I'm moving to the slide number 12. I was talking to you is that how we are going to utilize this project management principles as well as the software development life cycles. So we all know that in the project management principles, we always talk about that measure twice and cut once. That's the principle. We always follow that. Before you take any decisions, you must be doubly sure that what decision you are going to take it up. So that's the funda is always applied over here also. So how we do measure the things. So basically this project management principle, what we are going to apply that when we talk about the monitoring and control. So what we are going to monitor and how we are going to control. So the thing is, unless we measure, we may not monitor and we may not able to control it. So that's the complete concept over here, that in the software development life cycle, I must be able to measure what I can, but I must always try even if I'm not able to measure something. So for those things we should try to measure. So the concept, the principles over here is I should be able to measure each every details of the software development life cycle. And if we are able to do it, then the monitoring and control principles which are good for the project managers, they can do the better job in monitoring and control. Unless we do measure the software SDLC processes nicely with our quantified data, and we take the reference of our baselines of our organization, this monitoring and control process of the phases process of the project management principles, it remains as very much qualitative, and that does not give a right guarantee that you are delivering the delivery to the customer with the zero defects. So with this process, what we are finally we are trying to aim is, I am aiming for the happy customer. This is only possible with when I am going to deliver the customer with the right quality in the delivery, less number of the defects in the production system, and the effort which is utilized into fixing the bugs is going to be very, very minimal. So basically I'm trying always for the zero defects, so rework part is going to be almost negligible for me. So I'm also trying to give you some of the statistics which is just for our experience, that at starting point of any of the project is we must be measuring the size of the project, that what is the size of the projects, and we can adopt either the Kellogg size or the function points, and the SDLC chart where I was talking about the UCL and LCL. So basically in the next if you see that in the development defect density, we have the system of the Kellogg based sizing system. So we have standards to that any developer must try to find out at least 30 defects per Kellogg before he say that my code is stable and it is good to go for the next phase. The same thing, we have the target for the testing team that at least he must be able to find out at least 4 defects in per kilo by any means, either by the exploratory test or by the manual testing or by automation testing, and then he must be able to say that my delivery is good to go to the customer level. We don't stop only into the defect density level. We also work on the test case efficiency and development test case efficiency and the testing test efficiency. We have the benchmark that how many test cases we must try to say that yes, my test cases are sufficient. We also don't stop there. We also try to figure it out what should be the speed of the development, so that at this speed if the developer is working, then his productivity is going to be best, that he is able to deliver the good quality of the deliverables within the right time frame. So we have found out that 70 lines of code per percentage, if if we are doing a planning for the developers with the 70 LOC per percentage, then with average competency of the Java developers or the .NET developers, he should be able to do a write just to the quality of the code. The similar thing is we are having the test case execution, at what speed I must do the testing of my code. So we are having the experience that if the developer is able to test 30 test cases per percentage, then probably he should be able to do the right justice to the testing process. So these are some of the matrices we are just giving. I'm just giving to you. This is just the tip of the iceberg. We are having the very wide spread of the baselines data, and I'm just sharing a couple of data in front of all of you so that you can look back into your organization and say that what are the matrices the project manager should be able to look into this. Sorry, I'm again going to the next slide. So there are the couple of demonstrations. Some of the demonstrations which I would like to share with you is with this kind of the processes, measure and control process which we have adopted. I'm just going to give you the information that in 2012 we have been able to deliver 89% of our projects that went to the market that were the one-time UAT pass. That customer did the UAT testing and they didn't find even a single defects into that deliveries. So just kind of the one example I'm giving to you. In the year of the 2011 and 12, we were able to deliver 18 consecutive deliveries to the customer, which were the zero defect deliveries. That in the consecutive 18 deliveries, the customer did not find even a single defects. That was a milestone we had achieved. In the year of 2013, 12-13, we have already delivered 10 deliveries to the customers, where there were no defects in the 10 consecutive deliveries. What we have achieved by this milestone, why I'm trying to say that these milestones are important is the post-delivery support cost, which we talked about, that we say that after development there must be a maintenance team. So we always ask, what should be the size of the maintenance team? Basically, we just take one gut feeling and say that if the development team was 10 members, I must be having the 30% of my maintenance team. But that's just a gut feeling. But if you look at the data which we have found is the post-delivery, the cost of the support is just 3% in our development environment, in our environment, that we don't put up a lot of money in supporting our deliveries. We are very sure that the deliveries which are going to the market is to be zero defects. That the support maintenance team is very, very light. It's going to be just 1 or 2 people. Sorry. I'm really sorry. It's going back again. So with this, definitely the business people will definitely like to see that yes, what you have done so many things, but what you achieved. I'm going to share this some information, probably you will definitely appreciate it. The productivity of my team improved by 15%. We have the very precise way to measure that what is the productivity of my team actually. We improved the delivery efficiency by almost 11%. you can ask me the questions, what is the delivery efficiency post this session, and we increased the business growth onto the installed base by almost 10%, and our CSAT rating improved by almost 20%. So as of now, we are almost getting the 100 out of 100 CSAT ratings into our deliveries. So these are some of the things which business people will be very much curious to understand. Okay guys, you did a marvelous project management, you did a very good project management, good deliveries, but what is the output? Basically the points which are into the yellow, I'm talking about the CSAT. The business people like over this, and they say that yes, CSAT is very important for them. It's improved by 20%. The growth on the installed base of the business, it's improved by 10%. That's one of the dearest thing for them also. So business people just appreciate about this. These all the two things are happening only because of the good quality of deliveries with the project managers are delivering. So I'm just moving to the next slide. It's slide number 16. So I was talking a lot about the cost of quality. By this zero defect deliveries, we are trying to reduce the cost of quality, and this cost of quality has resulted into to creating a value to the customer, that the deliveries which we have delivered to the customer, which requires very less rework, and that really saves a lot of dollar for the to the customer. If the customer is able to save a lot of dollars, they are able to initiate new projects for their business. So those projects are again coming back to us. And finally, it's most important is if you just see a smiley on your customer face, that yes, because of these guys, we are happy customers. So that is the most satisfying thing which you can expect.